Hey, you all, Farmer Jesse here with a really big but exciting ask from you this week. In the show notes of this podcast and on our site and on our Instagram and basically everywhere we can put it is a survey we'd love for you to please fill out. But it's not just your average survey. It's a survey that could lead to a whole lot more small-scale organic farming research being done, led by our very own host, but also professional researcher, Natalie Lounsbury. No-Till Growers has wanted a research team for years, and by filling out this survey, you help us get one step closer to having extensive research capacity. But it all starts with this survey. The survey takes just a couple minutes. It's super easy, and we could use as many responders as possible. Find the link in the show notes, and thank you. Now, back to your regularly scheduled nerdy ear candy.
Hi, everyone. It's Natalie. It's hard to believe that this is my 6th episode for the No-Till Market Garden podcast. It felt super intimidating to commit to finding and interviewing 10 people, but it turns out it's been a lot of fun to talk with people I've admired from a distance and also with some of my friends. For this episode, I talked with my friend and colleague Sonja Birthisel. She is a weed ecologist and agroecologist by training, but her interests and expertise are wide and varied. We get into some of her research on the effects of tarping and solarizing on soil biology, important traits of weeds, weed seed predation, and her work in the community. I am really grateful for Sonja and all that she does, and I hope you enjoy our conversation.
Today's episode is brought to you by Rimmel Greenhouses.
Whether it's tomatoes to market, flowers in the spring, or your family's harvest, growing in a greenhouse protected from the weather provides the right environment that you need for a harvest that you can count on. Rimmel Greenhouses are designed for durability and offer the quality that you need to grow productively year-round. Visit rimmelgreenhouses.com to get a quote today.
If I may editorialize for a second, I own a Rimmel tunnel. I love it. We built it ourselves, and I really appreciated the quality of the tunnel as well as the customer service we received in the process, so make sure to check them out. Today's episode is also brought to you by Certified Naturally Grown. At the heart of sustainable ag is the belief that soil health and thriving ecosystems grow the very best food. Certified Naturally Grown is a grassroots certification program that recognizes direct market farmers using holistic methods and shows your customers that the products you bring to market are grown to the highest ecological standards. If you're looking for an affordable certification option that focuses on the thriving of local farms and foodways, you're going to want to check out CNG. Their peer-to-peer inspections create opportunities for farmers to connect, exchange knowledge, and build regional support between growers. Certify your produce, flowers, livestock, apiary, aquaponics, or mushroom operation today. Find out more at cngfarming.org. That's cngfarming.org. All right. Enjoy the show.
Thank you for joining me. I am really excited to talk to you. And so if you could just introduce yourself, and you are one of the people I know who probably wears the most hats. And so if you could tell me about your many hats.
Sure, Natalie. I'm really excited to talk to you too. And my name is Sonja Birthisel. I'm a weed ecologist or an agroecologist, among other things. So here are some of my hats. I wear that hat of agricultural scientist, which you could put some fancy buzzwords to. And I also am a member of my local town council, which I got elected to kind of as an activist. I do quite a bit of climate activism, direct action kind of work. And I'm a dancer. That's one of the hats I wear. I also do a lot of youth ministry, both with middle and high school aged people and with college aged people. And pretty involved in sort of state level political organizing as well. And one of the things that I've been most passionate about over the last couple of years is work on tribal sovereignty legislation that supports our tribes here in Maine. I'm from Maine. So those are a couple of the hats.
Yeah. Yeah, you make me feel like I do not have enough hats, but it's amazing. I always love talking to you because you have so many diverse interests and you're so active. So let's put on your agroecologist or your weed ecologist hat, and you do have, we should say, you have a PhD from the University of Maine.
True.
And so for those of you out there listening, the PhD process, it's a little different at every institution, but it does involve comprehensive exams. And it's this big looming thing where your committee can just kind of ask you anything, these oral comprehensive exams. So I'm going to send Sonja through her second round of comprehensive exams here.
What?
For the benefit,
I didn't know I signed on for this. Okay. All right. I'll play along. This is terrifying, but not as terrifying as the first time.
No, for the benefit of our listeners out there, I'm just going to throw out some words, and some of them are increasingly common in agriculture, and some of them are still kind of in the ecology realm. But I think that one of the things when scientists talk to farmers is that we have our own language, and it doesn't always translate. So if you could sort of translate these words and explain kind of the significance in the context of weed management, that would be great. So we're going to start, and these are ones that people are using more, but with seed bank and bud bank. Go.
Okay. Great. So the seed bank is the store of seeds in the soil that will germinate given the right cues. So it's just in a given plot of soil, all the seeds that are there, that if they get the right water and maybe a flash of light and temperature, they're going to pop on up and start to grow. And the bud bank is similar to that. So the seed bank is seeds. It can be either annuals or perennials. The bud bank is below ground storage organs, especially of perennial or biennial weeds. And those are some other big words that maybe we're going to get to. And that could include roots and rhizomes and tubers and bulbs.
And nutlets.
Nutlets, yep. So, and those bud bank propagules, they're sometimes called, could either be used for year-to-year survival, so just, a bulb surviving from one year to the next, or could be used to spread. So, rhizomes, quackgrass, for example, you would think of as a spreading perennial.
Yeah. So we're gonna keep going, but you can incorporate the seed bank and bud bank as we go forward. So diversity and abundance.
Okay. I'm going to start with abundance. Abundance is just the number of individuals of a species. And diversity is the variety or variability of species, or it could be diversity within a species too. So we could talk about genetic diversity within people, or genetic diversity within pigweeds. As the diversity of genes within those groups. But often when we talk about diversity, we're talking about, how many different species there are, or other ways of measuring what is the variety of species in a community.
Yeah. All right. So here we're going to sort of tie it together with this word that maybe isn't as common, but is like one of the linchpins of ecology. So filter.
All right, filter. So probably everyone can imagine a coffee filter where there's something that water and coffee grounds try to pass through, and you end up with the water and essence of coffee coming through that filter, and the grounds stay on top. And filter in biology or in a sort of farm setting acts just like that, but you could think about it applying to a population of plants where something happens that eliminates, that sort of holds out part of that population, and only some things get through. So that, for an example, could be a drought. There's a drought on your farm, and only the crop plants that are really hardy to those drought conditions that are maybe adapted to low moisture and to sort of hot weather are going to survive that drought, and some other stuff is not going to pass through that filter. It's not going to survive.
And so that does get me to the next word that I had on my list, which was trait. And so can you kind of integrate this idea of traits and filters and how a farmer can be thinking about traits and filters for weed management?
Sure, I can try anyway. So a trait is just a characteristic that one has. So in biology, we often talk about traits that are genetic traits, like, for example, in humans, eye color. And in weeds, it could be a trait like how many seeds it produces, or how quickly it grows, or how deep the root system tends to be in comparison to the bushiness of branches above. Those are all examples of traits. They're just the physical characteristics of a weed. And what trait something has can really impact how well it passes through or fails to pass through a biological filter. So drought adaptation is adaptations that allow a plant to survive drought are examples of traits that might help them pass through the filter that I just gave as an example. And kind of to tie it back further on, species that have underground storage propagules or a bud bank have a trait that allows them to survive winter, which is a filter that happens in our neck of the woods. There are some plants that don't have traits that allow them to survive winter here in Maine, but the weeds that we do have that survive and thrive have either a seed bank or a bud bank that lets them get through the winters.
Yeah. So one of those traits that I always find particularly interesting is periodicity. So can you talk about periodicity and how management can kind of manipulate that as a filter or use? Yeah. Go ahead.
Yeah, so I think of periodicity in terms of the timing of when a plant will germinate and emerge. So for example, like in the springtime, there are lots of weeds in a field that are getting cues to germinate, and you might have a flush of a number of different species, but different species have different mechanisms for when they know to germinate. And so some might have a periodicity that begins a little bit later. Some might have one that begins earlier. Some might kind of have flushes of weed emergence throughout the summer. And like hairy galansoga is an example of that. It doesn't have a lot of dormancy mechanisms. There's nothing that makes that seed be like, oh, now's a bad time to germinate. It just likes to germinate kind of all season long. And that means that farmers need to be wary in trying to control galansoga all season long. But oftentimes, one of the things that does give some weeds a cue to germinate is like a flash of light or disturbance to the soil. And so our timing of spring disturbance events can make it more or less likely that we'll get flushes of weeds, and the easiest time of their life cycle to control most annual weeds, at least, is when they're just starting to germinate, when they're in either like a white thread or cotyledon stage. So when they're just itty bitty, almost before you can see them, is the best time to be trying to kill those weeds and remove them from your seed bank and from your population that's going to be a problem in your crops that year.
Yeah.
I'm rambling a little bit, but
no, that's okay. I'm very much putting you on the spot, and I can chip in here a little bit too.
Please.
Like, I think periodicity is super interesting, and it's something that I know a lot of farmers observe like, okay, this is when these weeds come on. And, even within a group of weeds, like we might say the summer annuals, even within that group, there might be these differences in when specific weeds come. And some weeds, like say, for example, common ragweed it comes in this very, very discrete window. And if you pass that window, like 95% of the seeds that were going to germinate would have germinated in that window. And if you just get past it, then there aren't going to be more that germinate. So like timing itself as a weed management factor, I think is a really fascinating concept. And so that's why I find periodicity to be super interesting. If you know the weeds that you have on your farm and you know their periodicity, you can manipulate them by just either giving them the cues or not giving them the cues they need to germinate.
Yeah, absolutely. And ragweed's an amazing example of that.
All right, let's, I know I keep putting you on the spot, but one of the things I have heard you talk about before that I also find really fascinating is the idea of half-life and seed mortality. So a lot of people have heard the 1 year seeds, 7 years weeds, which rhymes. And so it's fantastic. But what is the story with how long seeds can last in the seed bank?
Yeah, so this is really interesting. And it's true that weeds can often last a long time in the seed bank, but it is also true that most of them don't. Only a few so like say you have a lamb's quarters plant that grows and escapes your weed management 1 year and rains down thousands of seeds into your seed bank. It turns out that there is actually exponential decay of the seeds coming off of that plant over time, such that within the first couple of years, half of those seeds are actually going to die, either through germination and being killed or through other natural causes, decay, that kind of thing. And then another couple years from now, another half of what was left is going to go away. And then in 2 more years, half of what was left was going to go away, such that by the time you get to 70 years out, the fraction of the original seeds that had fallen off of that plant is tiny, 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 tiny. Most half of the seeds that fell off are actually going to go away over the course of what that plant's half-life is. So half-life is the time it takes half of the seeds from sort of a particular seed rain event to die and go away. And that ends up being a predictable figure where half will go away within the half-life, and then half of that will go away within the next half-life, and you get exponential decay over time. Just kind of the same way that you do with radioactive isotopes for people who want to have a flashback to their high school chemistry classes here. Yeah. It's the same pattern that we see with life in the seed bank. And that's pretty exciting. And there are some things that we can do to manipulate that. So the half-life of an annual weed is going to be oftentimes longer in a system that's disturbed less often. But if we're, out there sort of tarping or gently raking, out there like intentionally creating a stale seed bed, for example, we can make it so that the half-life kind of increases for that species. There are things that we can do to deplete the seed bank more quickly.
Yeah. Hi, it's me. I'm interjecting here post-recording of this conversation. I'm not even sure what I think about trigger warnings, but after recording this, I felt like I needed to say something. I use some language here about weed seeds that is scientific, but nonetheless could be triggering for people who have experienced miscarriage or pregnancy-related challenges. If that happens to be you, I do know how you feel, and I'm very sorry. My science hat was on, and my human hat had temporarily blown off of my head. One of the, other than just sort of dying, I believe the technical term, which is really, like, it's really I don't even know if I want to say it, but the technical term is like embryonic death. Like the seed.
Oh, wow, that is dark.
I know,
but also accurate. It's an embryo in each seed. That's what we say in botany.
Right. So just the sort of natural embryonic death can occur because seeds can't last forever. But another way that seeds leave the seed bank is through seed predation. And you studied this for your master's research. So can you tell us a little bit about seed predation and what you found?
I did. Yes, and I can. Seed predation is cool. So it's what it sounds like, really. Seed predation is when there are things that eat the seeds of weeds in particular. I mean, they could be eating the seeds of anything, but we think of this as an ecosystem service. It's something the ecosystem does that's helpful to farmers in the context of naturally occurring organisms eating the seeds of agricultural weeds. And so seed predators include things like ground beetles, which even if you're not sure what they are, go Google ground beetles. You've probably seen them in your farm or garden. Also, mice are important seed predators, and birds, granivorous birds, as well as ants. Ants do some picking up of seeds and caching them.
I want to clarify. You said granivorous, not carnivorous.
I did say granivorous.
In case the word sounds similar. So yes,
granivorous. Grain-eating birds. Yes. Grain-eating birds, granivorous. Good clarification. So one of the questions that I get about the seed predation is people will ask me, well, okay, great. So they're eating the seeds of weeds. I see how that's advantageous. But why don't they eat the seeds of your crop plants? And that is an amazing question. And the answer is that most seed predation happens on the soil surface. Like once seeds are buried, even a fraction of an inch down, seed predators, especially beetles and other invertebrates or insects, are not going to be digging for them. Typically, they're foraging on the soil surface. And so if you're burying your crop plant a quarter or half an inch down, it's going to be pretty safe from seed predators. So I did a whole master's degree about weed seed predation, and this was a fun process. I ended up doing a pretty intensive on-farm trial where I partnered with a farmer in Dixmont, Maine, and just covered his farm with little seed predation assays, which are dishes that I put out with a known number of seeds. And then I would pick them up afterward.
Can I interrupt you for a second? Sorry. So another cool thing about doing this research that is just kind of a fun tidbit is that you can buy weed seeds.
That's true. You can. Well, it's sometimes hard to. So there used to be like a place in the UK that was breeding weed seeds and would sell them, and they went out of business partway through my master's degree, which was really a bummer because I still needed weed seeds for my research. And so then I found another place down in Texas that was selling some seeds, but I ended up also mostly going out and collecting weed seeds for my own research because sometimes it's hard to buy them. And I also didn't want to be bringing weed seeds onto a farm and introducing genetic diversity or introducing new species to that farm. So I was really careful that I was a lot of times using weed seeds that I'd harvested from that farm so that I wasn't going to be causing those kinds of problems, and tried to be really selective about what weed seeds I was using.
So you were saying weed seed assays, you put them out on the farm.
Yep. Put out like dishes with a known number of seeds and then picked them up afterward and counted how many seeds had gone away in order to measure how many of them got eaten. And then I also was like trapping beetles all across the farm at over 100 sample sites at 4 different time points. So I was really interested in like how how much seed predation is happening across this whole farm in different habitats. And this is a diversified vegetable farm. So there's a diversity of crop plants as well as cover cropped areas and some hay fields, sort of meadows. And there was like a wetland area on one side and softwood forest on the other side. So a really kind of diverse landscape. And I sampled seed predation across this, including in the forested and wetland edges of everything, to try to figure out, well, what is the sort of spatial arrangement of seed predation, and how does time point impact this, and what's the impact of habitat on this important ecosystem service. So really kind of a fun naturalistic study.
And what did you find?
I found that seed predation happened most in the crop fields and in that sort of forested wetland habitat, which is great news if you're a farmer. It's like nice that seed predation is happening in your crop fields as compared to some of the other surrounding habitats that you might have on a farm. And I will say it's like hard to extrapolate too much from one farm to all farms, but I think it's likely that similar things might be found at other farms. And we also found that within crop fields, areas that had more vegetative cover, so areas that were cover cropped or had like a quite a bit of sort of like beans or something that's got like bush beans have a nice amount of vegetative cover. Those kinds of things had higher seed predation rates than more sparsely vegetated crops or areas.
And were you able to separate out whether that was mice or beetles?
I was, to a great extent, and it varied a little bit by time point. So beetles were one of the dominant predatory forces, but mice and birds contributed quite a bit as well, and especially later on in the fall. So we sampled through October, and by October, it was cold enough that beetles weren't foraging as actively, but birds and mice continued to be active and eating the seeds of weeds through that time period. So I guess some like take-home things that I would recommend based on this study, if you're interested in supporting seed predators, are that cover cropping, in addition to the very many benefits that it has for other reasons, may support seed predators, which is nice. And similarly, wetland conservation, in addition to the very many benefits that it has, might support seed predators, which is also nice. And this is another sort of take-home piece, is that I wouldn't recommend delaying fall disturbance if seed rain hasn't happened yet. Like if you've harvested your crops and you've got a weedy field, but those weeds haven't set seed, it's probably still good to get rid of those weeds and prevent seed rain. But if you've got a situation where all those weeds have already dropped all their seeds before you harvested and are ready to clear that field, just leave that sort of stubble and leave those seeds on the soil surface and delay, tillage or whatever you're doing, in order to give seed predators a chance to have at those seeds and try to prevent them going into the seed bank.
Because they do actually eat a significant number of seeds. This isn't like just a little bit.
Yeah, this is like many percentages of the seeds that will drop.
Yeah,
it can be upwards of 50% of seeds get eaten right away. Although it does vary a lot by exact place. So there's quite a range in the literature. But I think you can assume they're having a real benefit.
Yeah. Yeah.
Today's episode of the No-Till Market Garden podcast is brought to you by BCS America. BCS two-wheel tractors are designed and built in Italy, where small-scale farming has been a way of life for generations. Discover the beauty of BCS on your farm with PTO-driven implements for soil working, shredding cover crops, spreading compost, mowing under fences, clearing snow, and much more, all powered by a single gear-driven machine that's tailored to the size and scale of your operation. We have been using a BCS tractor on our farm since 2014, and it has saved the day and leveled the workload more times than I can count. And I find new ways to employ it every single season. To learn more, view sale pricing, or locate your nearest dealer, visit bcsamerica.com. That's bcsamerica.com. To learn more, view sale pricing, or locate your nearest dealer, visit bcsamerica.com. That's bcsamerica.com. And while you're there, select tractors and attachments on sale through the end of this year. Today's episode is also brought to you by Farmer's Friend. In a world where the threat of food insecurity is quickly becoming the new norm, Farmer's Friend exists to equip, educate, and inspire growers to change the world through regenerative agriculture. Small farms are the future, and the future is now. If you need quality tools and supplies for your vegetable or flower operation, check out their growing selection of innovative and affordable tunnels, tools, tarps, and much more. Here at my home farm, we rely heavily on Farmer's Friend for our production. We have 3 of their Caterpillar tunnels. We use the silage tarps for occultation. Their row covers have gotten us through hard winters. And of course, the Quick Cut Greens Harvester has sped up our baby greens harvest tremendously. Visit farmersfriend.com/no-till today. That's farmersfriend.com/no-till. Or visit the link in the show notes and get free shipping on your entire order. All right, enjoy the show.
So moving on to your PhD research.
Sure.
So you did some really awesome farmer-driven research on tarping and solarization in Maine, which is kind of how we connected because we were doing different but related work during our PhD research. So what were your questions going in to your research, and what did you find? And I know it's a lot, so we can chat about it back and forth, but I guess just start with what were your questions?
Sure. Yeah. So this kicked off for us because a farmer had come and was doing a tour at Maine where I was studying, and in the process of like walking around and touring the research farm, asked a really thoughtful question that my advisor and I had never thought about, which is like, well, do you know anything about how solarization works in Maine? And like Eric, my advisor, and I were like, well, we know what solarization is. It's when you take clear plastic tarps and lay them on the soil, and you get hot enough soil temperatures to, kill weeds and plant pathogens. And so it's a tool that is used, but mostly in places like Israel or California that have hotter temperatures and more solar gain than we typically get. So we don't really know if it's been tried in Maine, and we sort of assume it wouldn't work. But yeah, we could try it. And so with this farmer, we did an on-farm trial at his place, and then another couple of farms, as well as a trial at our research farm. I got like a little $5,000 grant to kind of pilot some studies looking at solarization in Maine. And in part, we had this hypothesis that it was not going to work the way that it worked in California and in Israel and other places that it's been used a lot. We thought that instead of killing your weeds, putting out clear plastic tarps could be used to stimulate an early flush of weed emergence. And then we could pull off those clear plastic tarps and flame in order to kill all those emerged weeds, depleting the seed bank and creating an amazing stale seed bed. That's what we thought was going to happen, and what this farmer had kind of hypothesized and asked us about too as we were having this conversation. And so, yeah, it was with great surprise that I tried this out a bunch of different places and found pretty consistently that it worked better than expected. Laying out clear plastic tarps, as long as I did it pretty precisely, where I was tightly securing the edges and starting over a irrigated seed bed and that kind of thing, actually was sort of promoting some flush of weed germination under the tarps, and then causing a stale seed bed right away. Like those seeds that were apparently germinating were not getting very far. I would pull up my tarps and see lots of dead little white threads and sort of nothing else. So that was really an exciting finding, that solarization worked way better than expected as a stale seed bed preparation technique in our neck of the woods.
Yeah, and then that though led to some questions, and I used to get these questions too about, well, if we're basically cooking things, what is that doing to the microbes and the soil biology? And of course, in other parts of the world, like Israel and California, solarization is also used to control pathogens. So like what you looked at that a little bit too, and what did you find?
Yeah. So that was the question that you and I have probably gotten hundreds of times from farmers, like over and over again. Okay, great. That kills weeds. Does it also kill the good soil microbes? How does that work? And so I did a couple of studies to try to look into that. And these were, so I ended up doing a field trial looking at clear and black plastic, and measuring effect of tarping with black plastic, solarization with clear plastic on soil biological activity. And I found that it was sort of knocking back populations of good soil microbes to a certain extent. And then I did a more intensive study looking at solarization in a open field and inside a closed hoop house, with the thought that if we were going to be able to get temperatures hot enough to control pathogens here in Maine, that sort of double layer of getting extra heat might be a good way to do it. And also a good way to like test the hypothesis. Can we get temperatures hot enough in Maine that it would be a danger to, soil life in a way that we would want to know about? And I did find that there were some impacts, especially on soil biological activity, which is sort of this measure of soil respiration. It's like, how is all the biota in your soil faring, which is a pretty general measure. And then I also measured 4 different beneficial soil classes of soil organisms, and found that on those plates I was growing of beneficial bacteria and fungi, I didn't see a meaningful reduction in the open field of those colony counts, but in a closed hoop house where solarization was happening, I did see a decrease in fluorescent pseudomonads, which are considered to be beneficial. But there was an overall decrease in like soil biological activity, both in the open field and especially in the hoop house. So that is some suggestion that, yeah, you're knocking back some populations of microbes in these areas. And so it probably warrants further investigation. And our understanding and expectation is that populations of beneficial microbes should bounce back over the course of a season. But I think it's also important to know and to acknowledge that, yep, it's killing some soil microbes.
Yeah. Yeah, I know. It's so hard and frustrating not to have answers. And it's also so much work to investigate each question. And each time you do a study, it just kind of leads to more questions too. So yeah. It's still an open question, but I think that's a really good point that in most field settings in, temperate climates, the temperatures are not high enough to do, it appears not high enough to do, and I don't even want to use the word damage, but to knock back those populations too much. They're pretty resilient to the temperatures that those conditions create. There's one study that I remember reading about that I just found so fascinating, where I don't even remember where it was actually, but it was solarization, and they wanted to know the effect on arbuscular mycorrhizal fungi, which we know are these very beneficial fungi in the soil. And what they found was that it was a cool study design. So what they found was that the solarization itself did not negatively affect the AMF, but the fact that solarizing took out the weeds, basically, that if you didn't subsequently grow a crop that was an AMF host, then the populations would decrease. But if you grew a crop that was a host, then the populations would be okay. But basically, this highlights that like weeds themselves can be hosts for these AMFs. So when you take out the weeds in a system, you are taking out a biological component that has interactions with the microbes.
That's fascinating. Yeah.
Yeah. I thought that study always sticks in my mind as like, wow, it's not, you might say, oh, solarizing, that you might conclude if you had designed the study differently, solarizing kills AMF, but it's not the solarizing directly. It's the fact that then there are no weeds growing subsequently to act as hosts. So
yeah. Really, really brings us back to and this wasn't even in our vocab that we defined at the top here, but maybe should have been. But in ecology, we have this idea of trade-offs where, our management is designed to do a particular thing, but often comes with some kind of cost. And so I think like ecology and agroecology is all about trying to find a balance that will work to support the health of sort of natural ecosystems in conjunction with supporting the health of an agroecosystem in a way where we can grow the food that we need to be in balance. I found, for example, in my greenhouse solarization that I buried little bags of weed seeds to see how many of them died in the process of being in this really hot environment, solarizing under a greenhouse. And 98% of the seeds in my little weed bag did die in that greenhouse solarization, as compared to 64% of the seeds died in the field outside, which is still like, better than 50% sort of weed control. And so that's an exciting finding from a weed management perspective. Like, yeah, this could work really well for weed control. But then there's always that question of like, well, how much weed control is the right amount of weed control, given that, weeds are a blessing and a curse as part of a integrated complex system.
Yeah. And to clarify, what you're saying is not that those seeds germinated and then died, but that those seeds thermally died. The seeds themselves were cooked to be no longer viable.
Were cooked, apparently. Yep. Although by the time I dug them up and exhumed them, they were like so far like rotten and mushy and decayed that it was hard to tell whether they had like started to germinate and then died, or were like like before starting to germinate. It was like hard to tease that apart, but it was definitely the case that I could see.
So they were
cooked seeds.
They were either cooked, or they were also perhaps decomposed. Yeah. They were degraded. We'll use a generic term, degraded.
Definitely degraded for sure.
I love the point about trade-offs, and one of the things that you and I have also talked a ton about is this trade-off of using plastic.
Totally.
It feels so yucky, and I know that a lot of the folks listening also rely on silage tarps and other forms of plastic. One of the questions I had for you was, in your solarization research, did you find that you need new plastic, or can you actually use old greenhouse plastic?
Oh, thank you for this question. This is one I love answering. I found that I was able to do solarization really effectively with old hoop house plastic. So all of the research that I did on this topic was done using hoop house plastic that had been taken off after about 5 years of use on a hoop house, and I repurposed it in the field for solarization. And there were a couple of places where I threw a little duct tape on to patch some holes, but by and large, the tarp was still in good enough shape that that worked great. And there's actually a really cool study from the 80s that looked at new versus used plastic for solarization and found that gently used plastic can have better effects than brand new plastic because of the changes in optical properties as the plastic starts to break down. Actually makes it a little bit more effective for solarization, according to this study from the 80s, which I shamelessly quote whenever I can because that's the kind of fun fact I love.
80s was a really great decade.
Wasn't it though? Good music, good tarping research.
All right, let me think where I was going to go with this. Yeah, so the fact that you can use this old greenhouse plastic or hoop house plastic and repurpose it, get some more, utility out of it. That's actually very cool. So it lessens the blow of having to use plastic. And so one of the I'm trying to come up with a good segue, but one of the times that we discussed plastic a lot was during this working group that you convened on tarping and solarization. So can you tell me about, how you got the idea to convene this working group, how it worked, and let's just talk about that.
Yeah, totally. And I think your segue is perfect and kind of like hits the nail on the head because I think talking to you at one of the MOFGA farmer to farmer conferences or something, we were swapping notes about the research we were doing on tarping and talking to some farmers at the table who were also had been using this on their farm. And it occurred to me that we had this risk of reinventing the wheel, you and I, as we were studying something that was kind of similar and there was overlap, but at different universities, because you're at UNH and I was up at Maine, and we didn't have, we weren't working on a project together yet. So we didn't have a way that we were collaborating and swapping notes other than we'd run into each other at this conference. And so then I was thinking about I wonder, who else within the Northeast region is also working on this? And wouldn't it be cool to be able to swap notes with more people and make sure that we're not just all trying to answer the same questions and that we're, able to look at this from different perspectives. So I got together, I got a small grant from the Northeast IPM Center, and you were a co-author on that. Thanks, friend. And we convened a working group of farmers, extension professionals, and researchers who all had a shared interest or some experience and history with tarping and soil solarization. And then within the researchers, I tried to pull together some diversity in terms of people who were interested in plant pathology, entomology or insects, and weeds, since these techniques with tarps, we don't really know what they do to the insects. And you and I study weeds. We didn't really have the tools to be thinking about that in a sophisticated way. But wouldn't it be cool if we had some friends who were interested in that, was my thinking. And then I also tried to reach out to different states and organizations within different states. So there are people from Maine, New Hampshire, Vermont, New York, Connecticut, and Massachusetts who all got together in this working group to be essentially sharing information, swapping ideas, and trying to kind of build bigger collaborations across the region, and making sure that, practical experience and insight was valued in the process of developing research priorities. So yeah, that's how that came to be. And for me, it was a really valuable process. I'm curious, what sticks out to you about that experience, and anything else you wanted to reflect on?
Yeah, I also thought it was really valuable. And one of the things that I love about you is how collaborative you are, and how you just bring people together. And so I loved hearing from all the folks that were part of the working group. And we didn't solve everything. Like we
shocker.
I know. But it was really great. There was, someone from a grad student from University of Vermont who was looking a little bit at the insects, and I think she may have published some of her work now. And then we also did get into like recycling programs for plastic and thinking about that. And so it was very, very useful to me. One of the things that we did produce was a tarping guide. And so that, I think maybe for both of us, if we had known going in how much work that was going to be, we might not have done it, which is the story of so many things, right? But yeah, so for everyone listening, we produced this guide to tarping in the Northeast, and it's available through the University of Maine Cooperative Extension website. And our rationale was that there are a lot of books coming out, written, case studies of farms using tarps, and those are really valuable. They also cost money, and we were like, in the public interest, there should be something out there that farmers can look to learn about what we really know about tarping and solarization at this point. And so, yeah, we put together this tarping guide, and it includes an interesting sort of gradient of like tillage intensity, and all the different ways that you can use tarping and solarization. So from what you were talking about with kind of this stale seedbed technique, in a tillage-based system to draw down your seed bank, all the way to what I researched, which was, cover crop based no-till, and then also on to like the compost mulch systems. And we have, I think, 5 case studies too of farms that are using tarping and solarization in different ways. So it was a difficult process to get that out, but it was really great. So you and I worked with Jason Lilly at UMaine and Ryan Marr at Cornell to put that together. And so thanks for convening that working group.
Totally. Yeah, there are actually 6 farmer case studies. I just double checked.
Cool.
And they're pretty great. Everything from different methods of bringing sod into production with tarps to overwintering tarps. There's a number of topics, and I'm really proud of how this tarp guide came out. I think it's an amazing free resource. And if you want to find it, if you Google UMaine tarp guide, it should pop right up. But if you need something more specific, it's Bulletin 1075, and the title is Tarping in the Northeast, a guide for small farms. So should be freely available with your Google search.
Yeah, and there is a way to get the whole guide as a PDF. It's somewhat counterintuitive or non-intuitive to navigate to that PDF, but you can do it. It is available. So if you're looking for like the one PDF document, you can find it. All right. I think enough about the tarping guide. I want to move on to some of the work that you've been doing with climate change generally and with respect to agriculture.
Yeah. So when I started a PhD in weed ecology, I was really interested in using climate change as the lens through which I looked at this problem of how we can manage weeds in a way that's ecologically sustainable. And so my dissertation was about multi-tactic ecological weed management in a changing climate. So really trying to take a broad view of that. A paper that I wrote during my PhD that I'm pretty proud of is like a really thorough review of how does climate change impact already, and how do we expect it to continue impacting the suite of tools and tactics we use for non-chemical weed management. And so there's maybe like more to that topic and paper than will fit into this podcast episode, but I'd like welcome tiny follow-up questions and I would also say if anyone wants to read that paper and finds it behind a paywall, you could email me about that and I'd be happy to share a copy.
Yeah, I think one of the things that you highlight in that paper and that a lot of the folks listening already know is the value, the sort of increasing value of mulch-based systems for weed control moving forward in a changing climate. So you could talk about that a little if you'd like.
Yeah, I'd be happy to. So certainly mulch-based systems, and especially sort of natural mulches where you're adding organic matter to the soil, have a lot of utility, both in conditions that are too wet or too dry. And increasing moisture variability is one of the greatest climate change impacts that we're already seeing and that we expect to see moving forward. So mulch is great in that regard. And then an additional piece that is interesting about mulching as sort of a climate resilience practice that I think maybe not everyone has sort of thought about, it's a little bit less obvious, is that with the kind of like variable spring weather we've been having here in the Northeast over the last decade, at least, anything that gives the farmer more control over your weed management, when you don't know, like, when's it going to be dry to get into my fields to harrow or whatever. Anything that gives the farmer more control over the timing is advantageous. And mulch is one of those things. It's like there's an early investment if you're putting down like a thick layer of natural mulch that's going to last all season. There's an early season investment in time to make that happen, but it takes away the sort of, oh no, is it going to rain? Is it not going to rain? Stress later on in the season, and decreases the amount of time that needs to get spent later in the season. So you have control over the timing of when that happens in a way that's, I think, bigger than when you're reliant on more physical weed control based practices.
Yeah. And I know I don't imagine that you can pull the numbers off the top of your head, but I was looking at that paper the other day, and you did cite some numbers from sort of what forecasters or modelers predict will be the decrease in field working days in the future.
Yeah. I don't remember the exact figures off the top of my head, but I've looked at some of the National Ag Statistics Service data on this just over the last couple of decades. And it's already the case that we've seen a reduction in the number of days suitable for agricultural field work here in the Northeast, despite the fact that our season has gotten 2 weeks longer over the last 50 years. Because and that tracks with, and I believe is because of the sort of increased precipitation that we're seeing as a region, or precipitation that comes in these like heavy rainfall events that then makes fields really too soggy to get into for extended periods of time.
Completely shifting gears, you mentioned that you are doing a lot of you have done youth ministry, and what is your? This is another reason I love talking to you, because you and I have so much in common, and then we're also very different. And so I am fascinated to hear about your current paying job and just sort of how you weave all these aspects of your life together, maybe sort of a little bit of your philosophy.
Sure. Yeah. So I did like what appears to the outside world and some of my mentors like a complete 180 in my career a couple of years ago, but to me, it feels so much like just the continuation of the path that I have always been on. So I currently serve as director of the Wilson Center for Spiritual Exploration and Multi-Faith Dialogue at the University of Maine, which is basically like a multi-faith college ministry. It's a place for people of all different backgrounds and faith traditions, including atheists and agnostics, like absolutely welcome too. Place for people of all backgrounds to come together, learn from one another's perspectives, kind of grow into a comfort with being holistic human beings. And yeah, our mission is to work for social justice, honor diversity, and offer opportunities for spiritual growth, whatever that looks like for you. And I love it. I'm having a blast. And my like way that I got here is I've always been interested in education. I loved teaching at the university. And partway through the pandemic, I was teaching a big environmental science class right when we switched to online learning. And all of my students, it seemed, or the majority of my students were like having mental health crises as we transitioned to online learning. And I just wanted to be there with them in a way that normalized that going through that point in the pandemic was like really hard for all of us. And it was okay that they were not learning environmental science facts as well as they would have normally. Like that's understandable. And I just like was really gravitating toward wanting to have like conversations with students about big existential questions and the meaning of life and the bigger picture, and feeling a little bit constrained that my like method of interacting with students was to be teaching them environmental science. And so when the directorship of this organization that I'd been a volunteer at for a number of years came open, it felt like the obvious thing for me. It was like, oh, okay, well, that's a great opportunity to refocus on holistic student development that just like meets them where they're at and helps them try to become well-rounded human beings however they want to do that. And I can still do environmental science on the side and have that be a wonderful part of my life. But that's kind of how I got there. And my like own background in sort of ministry is something I grew up with. Like I grew up going to church, and it was sort of through learning about like world hunger as an issue when I was a kid in Sunday school that I first got interested in agriculture. You know, I learned that there are kids who go to bed hungry every day. And I was like, what? There are kids who die from hunger? That is ridiculous. That's like the worst thing ever. And it really put me on a path toward wanting to be part of solutions to feeding the world in a way that looked ahead toward the reality of climate change. And so that like early ethical development within myself is a big part of how I got to grad school. And it doesn't feel weird to me at all, but it's where I've circled back around to at this moment in time.
Yeah. What are some of the environmental science things that you do on the side?
Sure. So most recently, I've been contracting with the state of Maine to write a report on soil carbon sequestration and storage, which was, this is a sort of plan of work that was commissioned by a bill that passed the legislature last year. And a couple of colleagues and I studied the issue, wrote a report, and helped the department draft some policy recommendations that hopefully will circle back around this legislative session and, push forward our efforts on soil sequestration and storage at the statewide level. And then before that, I had a couple of postdoc positions that I let go to half-time as I assumed director of the Wilson Center, but didn't drop the ball on. And one was I was involved in a project called the Natural Climate Solutions Initiative at the University of Maine that was studying these sort of practices that can help sequester carbon in soil in agriculture and forestry, and another project that was like interviewing farmers and learning about their perspectives on climate change and what kinds of resilience practices are most going to work in a practical setting as part of trying to help inform policy that's not going to be really out of alignment with where people are at practically.
Yeah. And as part of that, just as kind of a side note, you and I actually, one of the ways we got to know each other really well was taking a very long car ride all the way up to Aroostook County in Maine to talk to some potato growers about practices. So I think back on that very fondly. I'm glad we got to do that car ride together.
That was a fun time. Yeah. I'm pleased that we know each other, Natalie.
Well, I want to thank you again for agreeing to do this. It was really fun chatting with you. Yeah, good luck in your future endeavors. I'm sure we'll be in touch.
No doubt. The pleasure was all mine.
Thanks for listening, everyone. I've got some more great conversations in store for you over the coming weeks, as you're probably spending more time in your greenhouse or even outside. And thanks to the crew at the No-Till Market Garden podcast for giving me so much freedom to talk with my friends and share it with you.
Hey, you all, Farmer Jesse here, just jumping in real quick to catch you up on some of what we have going on. Have you filled out the survey yet? That should be up for just a little while longer, but we need as many respondents as possible. This survey will help us get more research dedicated to small-scale ecological growers like yourself. You can find the survey details in the show notes or at our Instagram or website, or basically everywhere we can put it. Also, our No-Till Growers YouTube channel is back up and running and jamming again for another season of videos. There are new guides for onion and spinach production, a row cover buying guide over there, a seed priming primer, an essential guide to market garden tools, so many more things. Go over to YouTube and search for No-Till Growers and subscribe. Also, the No-Till Growers forum is just absolutely booming with so much good nerdy info. It's free. It's awesome. Go check it out at notillgrowers.com. If you'd like to support our work or support the idea of keeping farming information free in general, you can pick up a copy of the Living Soil Handbook at notillgrowers.com or one of the no-till hats, which are back in stock. We've got merch there as well. The proceeds from all of those sales at notillgrowers.com go to supporting our work. If it's benefited you and you have the means to pitch in, that would be rad. Or, even better, become a yearly or monthly patron at patreon.com/no-till-growers, where not only may you get discounts on our stuff, but at a certain level, or if you just bump up from one level to another, you get a shout out on the show. So, big shout outs this week to Closter Farm and Livestock Co., Susan South, Dan Glover, Scott Roser, Rob Soma, Sean at All About the Garden, Joseph Sanguinetti, Bill Altman, Ian at Grindstone Farms, Danny Rodriguez, Alex Savatsky, Pear Tree Hill Farm, Steve Burr, Stephanie and Alex, Stephen Smith, Jason Ruel, Ojai Roots, Scott Harris, Earth Care Farmer Jane Murner Cynical, Asia Smith, Tony Lopez, Clement, Judson Taylor, Grown Up Farm, Bob and Ann Patton of Hexhamshire Organics, Jared Kirst at Rivendell Farm, Dan Brisebois, Jay McCombs, Tim Baldwin, Esoterra Culinary, Steve Larson, Fiona and Donnie of Firefly Farm, and Jen Lawrence. Huge shout out to everyone who supports our show in whatever way that you can. The Patreon page, of course, is the lifeblood of our work, so we hope you will hop on board. And that's it from me. Thanks, y'all. We'll see you next week. Bye.